Number 2. The angle bisector theorem says that if an angle bisector exists within a triangle, that it's going to divide the triangle proportionally. So we're going to compare 15 over 9, and that'll equal z over whatever this is. Well, if the whole length of this segment is 32, then this part of the segment is 32 minus what's already taken, which is z. So we set up our proportion, and we have 15 over 9. Once again, think of this angle bisector as your fraction bar. It tells us how to set up the fraction. 15 is over 9, and z is over 32 minus z. Don't forget to put that expression in parentheses so that you remember to distribute. Cross multiplying, we have 15 all times 32 minus z, and that equals 9 times z, which is 9z. Distribute 15 to 32, and you have 480 minus 15 times z, which is minus 15z, and that equals 9z. Adding 15 to both sides, 15z to both sides, we're left with 480 equals 24z. And divide both sides by 24, gives us z equal to 20. Number 4, once again you have an angle bisector, but you have an angle bisector in two triangles. These two triangles are similar, so once again you're setting up a proportion because you have similar triangles. So you're matching their corresponding parts. So we're going to put the angle bisector over the angle bisector, 21 over 6. And that'll equal the side of the triangle x over the side of the triangle 8. And we know that x corresponds with 8 because x is in between the one arc and the two arcs, and 8 is in between the one arc and the two arcs. So it's just a matching game, matching your corresponding sides. Okay, first thing I'm going to do is cross multiply 21 times 8, which is 168, and that equals 6 times x, which is 6x. Divide both sides by 6, I get x equals 28. Number 7, once again, you do have similar triangles because these angles are vertical angles. So by the angle-angle similarity, you have two similar triangles. And because these triangles are similar, we're going to use a proportion to set up their corresponding sides and solve for x. Well, this is x, which will correspond with 8, and then 27 corresponds with 12. So cross multiplying, I get 8 times 27, which is 216, and that equals 12 times x, which is 12x. Divide both sides by 12, I get x equals 18. Number 9, this is the angle bisector theorem. An angle bisector divides a triangle proportionally. So we have, this is our fraction bar. We're just going to take 30 over y and set it equal to whatever this is over 8. Well, first we have to figure out what this missing segment is. If the whole length of that segment is 28 and 8 of it is taken, then what's left over is 20, or 28 minus 8. So this missing segment is 20, and we no longer need that 28. So we look at this as our fraction bar, and it tells us to set up our fraction as 30 over y equal to 20 over 8. I'm going to cross multiply, and I get 30 times 8, which is 240, and that equals 20 times y, which is just 20y. Divide both sides by 20. I get y equals 12. Number 12, it says AB and JK are altitudes. So once again, altitudes in two triangles are going to divide the triangles up proportionally. And it says that DAC is similar to MJL. As soon as you see that symbol, you set up a proportion. Alright, now we need to label our picture. AB is 9. AD is 4x minus 8. JK is 21. And JM is 5x plus 3. So we're just playing the matching game. 9 is the altitude, so it's going to match with the other altitude, 21. So 9 goes over 21. 4x minus 8 is opposite that obtuse angle. So it's going to match up with 5x plus 3, which is opposite the obtuse angle. Cross multiplying, I'm going to get 9 all times the quantity 5x plus 3, and that'll equal 21 all times the quantity 4x minus 8. 9 times 5x is 45x plus 9 times 3, which is 27. That equals 21 times 4x, which is 44x. Excuse me, 84x. 84x. And then minus 21 times 8, which is a negative 168. I'm going to start by subtracting 45x from both sides. So I get 27 equals 39x minus 168. Then I'm going to add 168 to both sides of my equation. So I get 195 equals 39x. And then divide both sides by 39. So I then have x equals 5. And then 15, this is the angle bisector theorem again. And this one's a little bit easier because we don't have to do any thinking. We just have to do it exactly as the fraction bar tells us. 6x plus 2 over 8 equals 9x minus 2 over 10. The hardest part is to remember that these are quantities. So we need to put parentheses around them, which will remind us to distribute. Cross multiplying, we have 10 all times 6x plus 2, which equals 8 all times 9x minus 2. 10 times 6x is 60x plus 10 times 2, which is 20. That equals 8 times 9x, which is 72x, minus 8 times 2, which is 16. I'm going to add 16 to both sides of my equation. So I get 60x plus 36 equals 72x. I'm going to subtract 60x from both sides of my equation. I get 36 equals 12x. And then divide by 12 on both sides of my equation. So x equals 3.